Hi, welcome back to Imperium Learning. In the previous video, I showed you how to calculate the future value where the interest rate that you apply has more than one compounding period per year. In this video now, I'd like to introduce you to the topic of the present value, and what's more, I'd like to show you how to calculate the present value when you're dealing with a single cash flow. So, to begin, what I'd like to do is introduce you to the present value. So the first thing that you should realize is that the present value is all about dealing with future cash flows. And so calculating the present value involves examining all future cash flows and discounting them by an appropriate interest rate in order to bring them back to the present. And so the present value is a useful tool for taking investment decisions and evaluating which decision could earn you the most money. And so to help you understand how the present value works, I thought it would be good to go through an example. So let's imagine today's date is the 1st of October 2020, and you expect that your child will start university in 5 years' time in October 2025. You anticipate that the total tuition fees for your child to complete the degree is $60,000. If you set up a bank account today that pays 7% interest per year, how much must you deposit immediately after creating the account in order to have $60,000 in 5 years' time? So in order to answer this question, the first thing you should be aware of is the relevant formula that needs to be applied. So as you can see, in order to calculate the present value, all you have to do is multiply the future value by 1 over 1 plus r to the power of n, where r is the interest rate and n is the number of years. And so if we apply the facts of the particular question to this formula, then what we're effectively doing is we're dividing 60,000 by 1.07 to the power of 5, and so as a result, the amount of money that we need to deposit today is $42,779.17. So, having shown you how to solve this problem in Microsoft PowerPoint, I now want to move over to Excel in order to introduce you to the PV formula. So now what we're going to be doing is we're going to be using this table on the right hand side of the worksheet, and we're just going to input all the variables based on the particular facts of the question. So just moving back to the question then, what's the annual interest rate? Well, looking at the second bullet point, it says 7%. What's the future cash flow? Well, it's just going to be $60,000. How many years? It's going to be 5. What's the number of compounding periods per year? Just 1. And so, as a result, the relevant interest rate that we're going to apply is just calculated by dividing H3 by H6, which is just 7%. So, in order to calculate the present value then, we're going to start by typing in equals PV and opening the brackets. And once you open the brackets, you should be able to recognize that the structure of the PV formula is almost identical to that of the future value formula. And so, as a result, what are we going to choose for the first argument? Well, we're just going to choose cell H7. What's the number of time periods? Well, it's just going to be H5 times by H6. What's the payment? Well, bear in mind that only applies to situations where we have multiple cash flows. So in this case, we're just going to put 0. What's the future value? Well, we're just going to choose 60,000 or cell H4. And then because we put 0 in the payment argument, we can just close the brackets here. So pressing enter, then you can see that we get $42,779.17. Now, as you can see, the number is in brackets and in red, which obviously means that it's a negative number. In the case of present value problems, I actually prefer them to be negative. And the reason for that is, once again, you have to think about the direction of the cash flow. So if you think about it, you're depositing money into a bank account. And so the direction of the cash flow is going from you to the bank. And so if you think of it like that, you're almost losing money. And then in 5 years' time, when you're coming to collect the money from the bank, the cash is now flowing from the bank to you. So in a sense, you're effectively gaining that money. And so that's why when you type it in the FV argument of the PV formula, you should not put a minus sign in front of it. So as a result, I'm pleased to say that this video is now concluded. In the next video, I'm going to show you how to calculate the present value when you're dealing with multiple cash flows in multiple different time periods. So, see you there.